I don't understand the reason. Everything is running fine. Don't worry, let's find some solution. It is updated only solo. No update is there. Already it is updated. Just wait. Let me log out and log in again. Okay. I changed the connection and trying something new. Is it okay now? कुछ लैग नहीं है ना? Okay. So let's start. So what is the lecture? What is today's plan? First part, what I am going to discuss here is left part. What is that? Decoders, encoders. Decoders is already discussed. And if required, okay. So let's start with the leftover part. So if required, I may extend the class. So depending on the topic completion, because yesterday already we left some little early. Okay, let's come back to this question which we left yesterday. Yes, Sushil. I'm planning according to the completion of the topic. Okay, I may leave early depending on the time. If not today, tomorrow, somehow depending on the topic, one day today we'll extend half an hour and we'll manage the time so that you also may not feel the load. Okay. So yesterday class we are discussing this problem. Then we got another problem of connection. Then we stop the class, right? Part 2 is from tomorrow, same as it is, the same class continuation only. It is already uploaded. So let me go to the class. So implement a 3-input majority gate using SOP, POS, active high, active low output 3 to 8 decoder. Okay. So what is 3-input majority gate? It is a sigma m of 3567. Okay, sigma m of 3567. So this function can be implemented. Listen here. This function can be written as product of max terms. What are the max terms? Please comment. I need some energy from your side. Okay. So product of the max terms 0, 1, 2, 4, not 1, 2, 3, 4. Surah? Okay. So please listen. Some problems may occur, some hurdles may occur. Don't lose your energy. Keep the same energy with you. Okay. So we'll resume with the same energy. These problems will occur just to test us, test our patience. So anytime when you start to study, some problems will always come in your preparation also. So with high energy, we should come back. So let's do this session. with more energy. Keep on commenting. So let me take first active high. Okay. In this session, in this problem, I'll explain the meaning of active high, active low, when this active high is more useful, when this active low is useful. Practically also we will discuss that. Just wait for some time. So now, so take a 3 to 8 decoder. A minute. So yesterday we stopped, I think, at this point. So ABC, you have 0, 1, 2, 3, 4, 5, 6, 7. And now you have these lines. These are nothing but your output lines. Okay, so you need to make 3 input majority gate. Sushil, what happened? You attended all my lectures or not? Basic lectures. Then why you are asking? Majority gate, we have taken example of industry, everything we have explained already. AB plus BC plus AC, 2 by 3 voting, 3 input majority gate. So you should revise, man. So what is the function? Sigma m 3, 5, 6, 7. And it is product of max terms 0, 1, 2, 4. So 3, 5, 6, 7 means take one OR gate, another OR gate, and another input from here. When majority is 1, output is 1. When majority is 0, output is 0. That's all. That's why it is called majority gate. So take this and connect it to OR gate. This will give you sum of the mean terms, so 3, 5, 6, 7. Sigma m of 3, 5, 6, 7. Now listen here. Now, how to do the same question with POS? That is, I want to take 0, 1, 2, and 4. Please be careful here. Okay. So, which gate I need to use? Okay, wait, don't comment. Don't comment. I will start the poll. Okay, get ready. Where is the answer? ABCD 1, 2, 3, 4 means ABCD. Right. Give your answer. Very good. Alcha, please have some sense. When poll is going on, you need not comment. When I give you a question paper in your GATE exam, immediately you should not shout the answers. Even you know the answers. So around only 20% gave the right answer. Harsh, Krishna, Deep, Aditya, Abhinay, Ganesh, Aishwarya, Himasri, Nishita, Bhargavi. So AND gate, most of you have given that is wrong answer. For POS, because you are using product of sum, it is an AND operation of the max term, so you may think it is AND operation. But listen here, these lines are not min terms. These lines are max terms. However, you use when Suppose 1 0 0 comes, fourth line will become 1 by default. It doesn't matter whether you are using it as SOP or POS. It doesn't matter in your decoder because it is active high. These are nothing but this 1 2 3 7 1 2 3 4 5 7 6 7 are represents min terms only. Okay, because whenever that particular input occurs, that particular output will become 1. Okay, so they are min terms only, they are not max terms. So you should convert min term into max term. For converting min term into max term, what to do? You should take bubbled AND gate. Take a bubbled AND gate. Right. Bubbled AND gate, if you take, then this min term will be converted into max term and it will do it. Bubbled AND gate is called NOR gate. What is the name of bubbled AND gate? Bubbled AND gate is also called as NOR gate. Is it clear, everybody? If you have doubt, you can ask me. You may have the doubt. Sir, what happens if I take AND gate? If you take AND gate, because the system don't know now whether it is min term or not. When you give any input, for example, you give 1. It don't know whatever your function, that particular line will become 1. Remaining all becomes what? Zeros. What does it mean? These lines are representing min terms only. So if you take OR gate, any one of them is 1, output is 1, it is satisfying directly. But if you take AND gate, always any one of them is always 0, your output is always 0. That is not required. AND gate is possible if it is active low. Please understand. Is it clear what I'm saying? I am taking my input is 0 0 1. Then I got like this 0. First one is 1, remaining all are zeros. Then what happens? This gate should give me 1. Now you check whether it is doing or not. This 1 is converted into 0. Then you will get 0. Any one of them is true, you will get 0. For example, see here. This will give you product of max terms 0 1 2 4. So what does it mean? Both are same only. Please understand. This and this are not different. Both cases your answer is same. For 0 here also for 0 1 2 4 it is 0. For 3 5 6 7 it is 1. Same way here for 0 1 2 4 it is 0. Remaining cases it will be 1. If you have doubt, still you have doubt, any kind of particular doubt, please ask me. I can explain. You should not use AND gate because these are not max terms. Please feel free to ask me. Abhijit, you have any doubt? Still you have doubt? Please ask me. Don't hesitate. What happened? No comments are coming. Okay. Output is 0 for all inputs, Aman. You take AND gate here, for example. You assume it is AND gate. Then you know simple blind rule. For a decoder, only one input is 1 at a time. Remaining all will be by default 0. If you take like that, AND gate output is 0 for any input. Is it clear, Aman? It should be 0 only for 0 1 2 4. Okay. Someone is having that issue. Let me repeat little fast. Okay. So please understand these are representing min terms only. To convert into max terms, you should take inverters here. Okay, clear? You should take inverters. If you take AND gate, it will not do your job because these are not max terms. So because you should to convert the min terms into max terms, you should take bubbles here. That's all. That much simple. No confusion at all. Is it okay, everybody? Shall I move further? I need reply. Very good. Very good. So let's start here. Active low. Active low. So in the active low case, let's see what happens. Okay, same function f equal to sigma m of function is 3 5 6 7. product of max terms 0, 1 to 4. Let me do the same question again for max terms. So now it is 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. So it is a 3 to 8 decoder. A, B, C. What is the he function here? This is the question given now for the function product. What is that? Majority gate function. They ask you to implement by active high and also active low. We have already done by active high. Now we are trying by active low. Yeah, this is the question given. Majority gate question. That gate you need to implement using active high and active low. We are doing active high is done. Now active low. What is the meaning of active low? By default, all 0. By default, all are at 0. Sorry, all are at. I'm sorry. All are at 1. When you give input, they will become that particular line will become 0. When you give the input, that particular line will become 0. Simple rule. Here, how to implement the function using POS? Now these are representing, these lines are representing max terms per. Okay, please understand why. Because when, but for example, what is the answer here? All are ones na. Just listen here. All are ones. If that input comes, for example, 0, 1, 0, this particular input comes, then second line will become 0. Remaining all will be ones. When the input comes, it is becoming 0, not becoming 1 na. So this is representing min term or max term. Comment here. Yeah, this is representing max term because when the particular input occurs, it is becoming 0. Okay, very good. Okay, so these lines are representing max terms for active low. Please understand. In general, you will be having some enable. You take enable bar or enable, it doesn't matter. Okay, so now please listen. So how to do this for the POS? Sum of, sorry, product of the max terms is 0, 1, 2, and 4. Take all of them and apply which gate? Please comment. Apply which gate? That's all. Your job is done. Product of max terms 0, 1, 2, 4. If you want to implement by SOP, take this 3. You can say you can do like this or 3, 5, 6, 7. Okay. Now you should use bubbled input or gate. Because that bubble and these bubbles cancels, that is conversion of min terms into max terms. This is bubbled input or gate, which is nothing but which gate? NAND gate. It is F equal to sigma m of 3, 5, 6, 7. NAND. Is it okay? This problem took so much of time yesterday also, right? So finally we are able to do this question. So shall I move further? Very good. Yes, yes. Finally we reached the destination, hopefully. Very simple, Swapnil. Bubble is there, active low. No bubble is there, active high. Or in the output is represent with Y0 bar, Y1 bar. Bar is there, na, active high, otherwise active low. If it is self-dual or not, doesn't matter, man. Whether it is self-dual or not, doesn't matter. Min terms and max terms never be same. Even they are same also, it doesn't have any meaning for you. You just take the line from both the points. What is the problem? Enable depends on the internal logic. You may have 2 enables, 1 enable, 3 enables also, depending on the circuit. Don't worry. It is a self-dual anyway. It is a majority gate. It is a self-dual. Whether it is self-dual or not, your process is same. It doesn't matter. Yes, Amitabh. Enable examiner. See, examiner give you bar or bubble. You treat it as active low and give 0. Otherwise, active high, give 1. That's all. There is no chance of confusion for you. Okay. So let's move. You may have the doubt, sir, why we should use, which one is better for us, sir? Active high, when to use active low. So let me give you that meaning. Active low means when it is activated, it becomes low. Okay, when it is activated, it becomes 0. Meaning kya? Otherwise, it is 1. That's all. Okay. So now let's do the next part. What is the next part is? I mean, let me explain you. Active high and active low. Okay, let me try to explain you in the better way. What is the mean? Why when you use active high, when you use active low? Okay, when it is active high, you need to give 1. Yes or no? Your system should be given once. Okay, when active low, when system should be given zeros. Please understand this. For example, okay. Suppose you have some LEDs like this. You take it as LED. Okay. So some system is, you have some digital system which is driving these LEDs. So the digital system should give you 1 here to drive these LEDs. Yes or no? Yes or no? What happened here? No comments are coming. You understand? You understand? Who need to give the power to all LEDs? Suppose you give 10100 something 1. You need to give 1 means 5 volts power should be given to all the 3 LEDs. Okay. For example, I have 11 all zeros. I need to give ones to these 2 LEDs. Remaining all LEDs I need to give 0. For example, I want to switch on all the LEDs. Then this system only should give power to all the LEDs. Okay. This system should act like a source and drive these LEDs. It may be or may not be possible, depends on the power supply available to this system. It is having the capability to drive it or it may not have the capability to drive it. Will you accept it or not? Its transistors etc. will have some limitation, IC equal to beta IB conditions and all before reaching the saturation. Okay. It should not be less than that, like that. So it is having some limitation. It may be able to draw or may not be able to draw. Okay. I mean, may be able to source or may not be able to source. There is another case. I can design the same digital system like this also. You have a digital system. It can be your decoder, it can be your encoder, it can be anything, doesn't matter. Now, here I already provide VCC externally. Externally, I will provide the power supply required for to drive these LEDs. Only my digital system should provide me what? Ground. Ground means zero provide kiya to it will work and it will you will be getting the current. Yes or no? Then the LED will be on. So it depends on your feasibility. Sometimes it may be you may be happy to provide the power supply externally so that your system need not drive these LEDs. It should just give you zeros only to drive. So in this case is where you call active low, and this is the case where you call active high. Yes, right, Asif. So this is also having another name called common. Which terminal is common here? Negative terminal. Diode negative terminal is common to all. Na? It is called common cathode. What about here? Anode is common to all. It is called common. Okay. Here your system is acting like a collection of the currents, sinking. It is a sinking the currents. Here it is acting like a source to the currents. Is it okay now? You understand the practical reality of active low and active high outputs. So here I need to just give zero to do my job. You want more? I can give little more depth also if you want. Okay. So let me give you little depth if required. Okay. So let's go little beyond. Okay. Generally we discuss this in the logic families topic, but let me clear this part. So this is A, this is VCC, and this is your A bar inverter, and this is driving some circuit. Okay. So this is driving your circuit. I already told now it depends on Sura. Your question may be answered now by from this exam. So you take this risk. Okay. Now please listen. And generally, this is what we call inverter. This is your transistor. Suppose you give one here, or you give zero here. If you give zero, what happens here? This part will be off or on. Very good. Off. It is off. Off means cut off. You remove this, and this is working like a source. I'm just drawing the internal circuit of your gate. Internal circuit of the gate. Okay. So this is acting like a source. It can deliver how much current? What is the source capability? VCC, right? Ah, okay. Source its own VCC it is having. Based on that, it will deliver this much. It cannot deliver more than this. So, depending on your circuit configuration, we should decide how much is required here, how much this fellow can give. Based on that, we should do your design. This is one method. It can be reverse also, na? VCC, you have a resistor, you have A. Okay. So let me connect the same similar way. You may have some circuit, some device, something here. Make this A equal to 1. Then the transistor Q1 will be on. If it is on, it is like a short circuit. Now it is attracting the total current of this network from top part. You understand? This flow current will be taken by him, and this circuit current will also be taken by him. So in this case, it is called sinking. Okay, this is called as sourcing. This is what we call sinking. Sourcing has a limitation based on this resistor value, and this is VCC. Similarly, sinking also have what is the limitation? Sinking limitation is IC should be less than beta IB. Your transistor, I hope you know this, because this is the condition. The transistor will be in the saturation. It should not come to active region. For transistor to be on, it should be in the saturation. Okay, so whatever you are giving from this part and from this part should not exceed this. So this is also having some limitation. This is also having some limitation. So depending on your circuit availability, everything, we may select for go for active high here or active low here. Here it is working like a source to drive them. It is working like a sink to collect the current by providing zero. Is it okay? So little circuit knowledge is required. So when you become a designer later, you may be doing all this stuff. You may be playing with your CMOS gates and all. Okay. So shall I proceed further? The circuit may be another digital gate or it can be anything. So let's go. Okay. So let's take the next part. Please don't say stuck. Thank you. I will be more what we call disappointed than you. If one day it happens, it is okay, but not. I mean, from my side, it should not happen every day. Oh, started. Is it fine? Okay. Thank you. Thank you. Okay, fine, fine. So let's move encoder. Prank किया क्या? Oh, very good. Encoder. Encoder is a combinational circuit. I already told you it is used for code generation and all those stuff. So let's start. First one. It is just reverse of your decoder. 8 by 3 encoder. Rajendra, you are new to class or what? Please answer, Rajendra. You are there in the previous classes. You are there in the previous classes. Already, I mean, what we call day before yesterday, we have discussed where we use encoder, where we use decoder, everything. Okay, encryption, decryption, transmission, receiver. Okay, basic part is already discussed in the day before yesterday. Okay, anyway, don't worry. Now also we discuss this. I mean, when I explain the part, then we discuss it again. Yeah, that is one simple example. Not only that, just wait. I will tell you different examples. I mean, different applications also. One minute. So this is what we call normal encoder. It contains 8 inputs, say 8 by 3 I am taking, and 3 outputs y2, y1, y0. And you will also have some enabling. How it will work, let's have some analysis. So please understand here, you have 8 inputs and 3 outputs. Simple way is, as someone told me, who is that? Yeah, who is that? Sushil told it is like a octal to binary converter also. That is also true. So let's do that. So please see here, you have the inputs. Enable I7 to I0 are the inputs, and what are your outputs? Y0 to Y0, Y2 to Y0. So just let's fill this table. So tell me, when enable is zero, your input can be anything. What is the output you get? It can be all zeros. Okay, fine, very good. When enable is one, so here, what is our assumption is normal encoder, only one input is one at a time. Only one input is one at a time. So if your I0 is one, you may get all zeros. If I1 is 1, 0, 0, 1, I1, I2, I3, I4, 5, I6 is 1, and I7 is 1, all will be 1. So here you may have some doubt. You have some doubt or not? Yes, Asif is having some doubt. Some people are having doubt. Yes, very good. Ask me. Ask. Your doubt is, sir, these two cases, your answer is same. Yes, I know, I know. So, how to justify that? Listen, it depends on your application. You may be taking all zeros here, or if you want better system, better design, you should take it as three jets. A jet kya sir? Jet is nothing but high impedance state or open circuit. In that case, you may not get the same in both the cases. Okay, so both are possible. It depends on your application. If it is zero is okay for you, no problem. If zero is also one output, so I don't want both of them same, then we can move on. Okay, that is just wait. Don't care means what? Where is don't care? At the output? No, it should not be don't care. It should be disable. When you disable, it should not do any job. Then why to take enable input? Yeah, yeah, you can check. Okay. Please listen, Rishi. When I naught is 1, I made all zeros. Just binary conversion. When I1 is 1, 0, 0, 1. When I2 is 1, 0, 1, 0. Like that, when I7 is 1, I made all ones. Okay, that's what I said now. Please listen. It depends on your system. Whenever enable is 0, your output device may be disabled. If it is fine for you, then you may not worry about both of them same. You may your system design, it depends on internal design. This enable may be common to some other system also which is taking its output, then no problem. If they are having separately 00 is also one state, 001 is another state, then there may be problem. I mean, in this case it may treat it as one state, in this case also same state, then it may be problem. In that case you may use the tri-state buffers, not an issue. Leave that part. Now come to design. Let's design this. What is y2? What is y2? Please tell me. Forget about your enable. When y2 is 1 man, please tell me. 4 cases are there when y2 is 1. What are those 4 cases? When, just see this. When I4, I5, I6, I7, very good. So you can say that it is nothing but when any one of them is 1, your output is 1. Okay? Similarly, just wait, Rajendra. Let me complete this part. Okay? Tell me, Y1. What is Y1? It is a 2, 3 and 6, 7. I2, I3, I6, I7. Now, what is Y0? Y0. Y0 is I1, I3, I5. You understand like this. And last one is for I7. Here, what is the assumption? Assume only one input is equal to 1 at a time. Now your doubt is clear, Rajendra. What is the assumption? Out of the 8 inputs, our assumption is only maximum only one input may be equal to 1 at a time. Not both two, 3 inputs more than 2, 3 inputs are 1 at a time. That is the assumption in this table. This is the assumption required for which encoder? Normal encoder. Yeah, it is active high only. Okay, so is it okay? So if you want to design it, let's go for the design also. What is there? Why it is not the rule, man? A normal encoder, that is the rule only. Now see here. What is that? Y2, I4, I5, I6, I7. Next, what is that? I2, I3, I6, I7. For the next one, I1, I3, I5, I7. Okay. First listen, Rohit, then we can come back your doubts. Just listen first. Let me complete, Rajendra. You can ask your doubts. Okay. Now listen here. You cannot say more than 1 is 1 or 2 is 1. It depends on the system. So now listen. Here you may take one extra gate with enable, and here another AND gate with enable, and here also another AND gate with enable. What is this system doing? When enable is 1, it will transfer y to y1, y0. When enable is 0, all are zeros. This is one method. Otherwise, what I told, take a buffer. What is that buffer? Tri-state buffer. This last lecture we already discussed now. So in this case, what happens when enable is 1, your y2, y1, y0 will be transferred. Otherwise, it will be equal to open circuit like a high impedance state. Is it clear? Okay. So let's check whether it will work or not. If let me take wildly some number I5 equal to 1, what is the output? Forget about enable. You know the enable concept. If I5 is equal to 1, I5 is 1. Where is the I5? Here also I5 is 1. Assume remaining all are zeros. Remaining all are zeros. Remaining all are zeros is our assumption. For example, if I5 is 1, remaining all are zeros. This OR gate is 1. This OR gate is 0. This OR gate is 1. Exactly 101. It is working happily. Is it okay for you? Like that, for any input, it will work happily. No problem. But now, and also I6 is equal to 1. Two inputs are 1 at a time. Suppose if two inputs are 1 at a time, then what happens? I6 also 1. I6 also 1. Then what happens? 1 plus 1, this will give you 1. Okay, this will give you 1. And this will also give you 1. When I5, I6 both are 1, so this is the output you will be getting. Okay, some people are more happy, right? But this is wrong answer. How it is wrong, sir? Listen here. Say 5 and 6 are fighting each other to give the answer as 5 or 6, but 7 won the match. Like 5 and 6 are playing the match, so winner is 7. Okay, Rajendra, I think first follow your class properly. Okay, why are you worrying to comment priorly? Please listen. First, follow the class. Okay, then only you can enjoy the class. So 5 and 6 are fighting, but who won the match? 7 won the match. It doesn't have any sense. Yes or no? Right? Right. So in this case, what to do? We should have some other design. So this design will not work properly when. So those people are who won the match. Someone won the match. So please listen. So what is the conclusion I can give here? Listen. Normal encoder will not work properly if more than one input is one at a time. So this particular design will not work when more than one input is equal to one at a time. So listen here, please. This point is clear. This will work only when one input is equal to one at a time, not more than one input is equal to one at a time. It will not work properly. Now go back. So let's take one example. Let's take one example practically. For example, there is a computer. Okay. So computer is having 8 devices, 8 IO devices connected. This is a practical application which regularly happens here. 8 IO devices are connected, like your keyboard, mouse, printer, whatever maybe. Some 8 devices are connected here. So one of them has asked computer to access the data or transfer the data, whatever may be. Okay, to read or write the data. Some I5 has asked the data. And also I7, this fellow has also asked the data. I should generate the address of 5 or 6. But what I did, I generated the address of 7. So 5 and 6 asking help of the computer. Computer is having only one way. It can help 5 first, 6 next, 6 first, 5 next. It can do that. But what I am doing is this system will help 7, which you don't want any help. Practical meaning, you understand where you can use this encoder? Yes or no? Please comment. Very good, very good. Now, so to avoid this disadvantage, we go to the next one. What is that? Priority encoder. What is priority encoder? When more than one input is equal to 1, it will take high priority into consideration and output will be either highest priority input. For example, you got 5 and 6. Whichever is having high priority, that will be taken. So for example, for the same time, two of your friends called for party. One boyfriend, one is girlfriend. So you have your own priority, you may go to any one of them. Right? Similarly, we will give priority initially. System is having their own priority. According to it, we will decide which particular one is to be responded first. Okay. So girlfriend, boyfriend, girlfriend, wife, it depends. Okay. So right now, no calls for party. Okay. So call for online studies only. Okay. Let's see here. Normal encoder will not work properly if more than one input is equal to 1 at a time. Okay, listen here. So Aditya is waiting for parties, right? Normal encoder will not work properly if more than one input is equal to 1 at a time. Okay, we can overcome this disadvantage by using priority encoder. Okay, in priority encoder, if more than one input is equal to 1 at a time, highest priority is only considered. So out of them, who is highest priority, we should go for them. Okay, so that will come now what we call 8 by 3 priority encoder. But before going to this, any kind of doubts in the previous part, please ask me. Now, Rajendra, any doubt you ask? Rahul, Rohit, anyone having doubts, please ask me. I am happy to help you. In computer, when you connect the interrupt cyber devices, we use this encoder inside. Okay, priority encoder will be taken, and that will take care of your addressing and all. Rohit, yeah, simple. You, Rohit, please tell me any doubt in this table. It depends. It's your own choice, Rajendra. You can take I3 as high priority, I7 as least priority, randomly also. We discussed that, don't worry. Okay, simple. When I naught is 1, all zeros. When I1 is 1, 0, 0, 1. When I2 is 1, 0, 1, 0. When I3 is 1, 0, 1, 1. It's a binary equivalent only. When I7 is 1, triple 1. Okay, got it. Very good. Any issue with voice? Okay. Oh, so priority has become more priority. Okay, so priority. So 8 by 3 priority encode. So high 7, 6, 5, 4, 3, 2, 1, 0. And you have one enabling. And you have three outputs. Y2, Y1, Y0. And here you have 8 inputs. This is I7, I6, I5, I4, 3, 2, 1, not. You take any priority of your wish, whatever the way you like it, you can take. I am taking this as highest priority and this one least priority. 7 has the highest priority, 0 is the least priority. That is what I am taking. Okay, there is no strict rule here. You take reverse, you take from middle to bottom, you take any random way, that is also true. Is it clear what I am saying? There is no strict rule. Priority in any order, but change design accordingly. You should change your design accordingly. Accordingly, you should make the design. Now, I am making the priority encoder with 7 as the high priority and 0 is the least priority. So now the table changes, simple change. Please observe here. If you want, I can zoom also. Right. So just compare with the previous cases. Now you observe what is the difference. What is the difference you observe here? I took 7 as high priority. Na? Earlier case, when 7 is 1, I took remaining all zeros earlier. Earlier, all of them are zeros. But now, don't care. Means when 7 is 1, remaining I don't mind. 6 is 1 or 0, 5 is 1 or 0. Remaining all ones are not, no problem. 7 is my best friend. When 7 comes, I don't worry about the remaining friends. I will go with 7. Okay. Okay. If 7 friend is not present, then next priority is given to whom? 6. So 7 should be 0, 6 should be 1, then 5 can be anything, 4 can be anything, 3 can be anything, remaining other friends can be anything. So 7, 6 are also not present, then 5 will get the chance. Remaining can be anything. Okay. So 1 minute. So when in the design you are converting binary, now if you want, you can convert into gray code. If you can't, you can convert into XS3. It is up to you only. Here we are making it as a binary code encoder. You are only writing these output lines now. You make your own code, nothing wrong. And this fellow can be all zeros or triple Z, depends on the design. So least priority is I naught. When no one comes, we give to I naught. So whether it is GF or BF, it is up to you. Or it may be your brother or sister. Okay. So fine. You understand here. Now the design changes. So how you will be designing, that also we take one example. Don't worry. But please understand now the design changes like this. Table will change. This point is clear, everybody? So I cannot design this 8 input because 2 power 8 combinations I need to take and make the simplification. It is not feasible. So let me design a 4 input 4 by 2 priority encoder. This is generally the table of 8 by 3 priority encoder. Okay. So now let's make 4 by 2. This I will design and show you now. And also we will prove it is following priority. 8 by 4 by 2 priority encoder. Okay. So this is what we call 8 by 3 priority and 4 by 2 priority encoder. So let's design with I3 as the highest priority and I naught as the least priority. I3 as the highest priority, I0 as the least priority. Is it okay, everybody? Let me take some water. Let's design. So please see this table. Is it? I hope it is visible. So what I made it is a 7 as the, sorry, I3 is the high priority. Next I2, next I1, next I0. Yes, I have done it. Otherwise, it will take so much of time. It will waste our time. So I took that extra time. So here all zeros. High priority is, this can be 0, 0 or set 0. Okay. Now please listen. What is y1? Tell me what is the expression for y1? It is sigma m of, forget about enable for some time. Don't worry about your enable. Remaining part, you tell me. It is 1 for 2 cases here. Y1 na answer. 1 for 2 cases. What are they? It is 1 for, not like that, not like that. Okay. Otherwise, I'll write. Wait, 1 minute. Not 2, 3. Not 2, 3. Okay. So here, you should write your y1 is 1 for 2 cases. What are they? 0, 1 double cross and also 1 triple cross. Yes, 0, 1 double cross, 1 triple cross. For these two cases, it is 1. Everybody accepted or not? I3, I2, I1, I0. When I2 is 1, I3 is 0 or I3 is equal to 1 with remaining as don't cares. That is our intention of the design. Okay. So you can say it is 0, 1, double 0, 0, 1, 0, 1, 0, 1, 1, 0 and also 0, 1, 1, 1 for this part. What about this part? 1, triple 0, 0, 0, 1 and so on up to all ones. So what is this answer? Sum of the min terms, what are they? 4, 5, 6, 7, 8, 9, 10 up to 15. Everybody accepted here, no doubt in this now. It is very clear, I hope. What about why not design, sir? What about why not? What about why not, man? You should tell me, please tell me. Why not is 1 here and here. You see 0, 0, 1 cross and 1 triple cross. That is 0, 0, 1, 0 and 0, 0, 1, 1. 1 triple cross means 1, 0, 0 to 1 triple 1. So what is this? Sum of the min terms 2, 3, not 4 here. It is 8, 9, very good. 10 up to 15. 8 to 15. Is it okay? Accepted? So can I move further? Very good. So I am designing this. Please understand. What is y1? Sigma m of 4, 5, and so on 15. So these are your inputs: I3, I2, I1, I0. It is 0, 0, 0, 1, 1, 1, 1, 0. Now sum of all minterms from 4 to 15. Similarly here you take I3, I2, I1, I0. Be careful. You maintain social distance. COVID is joined. Don't worry, Aman. Anyway, after completion, we can revise. Just follow this part. Okay. Okay, fine, fine, fine. Come back. Listen here. Listen here. Is it clear? Aman, you can check. Priority encoder is like this. When high priority occurs, remaining can be any value. Any value means don't care. When high priority is 0, next one is 1, remaining can be any value, then you get 1, 0. When these two are not present, then 1 is there, then 1, 0, 1. Nothing is present, I0 is present, that is the least priority I took. Like this. It can be any priority, don't worry about it. Okay, it is according to our design. Now I am writing expression for y1 and y0. Y1 is 1 for here and here, that is 0, 1 double cross and 1 triple cross. For that I made the minterms. Y0, 0, 0, 1 cross and 1 triple cross. For that also we made the minterms. Now let's fill this table and now implement the K-map. That will finish your job. So it is an octet and another octet. Similarly here one octet and one quad. Okay. So what is your y1? I3 plus I2. What is y0? Here I2 bar I1 plus I3. Is it okay, everybody? I just followed this K-map and got the expression. Everybody accepted? Very good. Now listen here. So this is the figure given. Figure we need to make. Your y1, y0. Forget about enable for some time. Now listen here. If I2 equal to 1 and also I1 equal to 1. You know, now out of the I2 and I1, what is high priority? Out of I2 and I1, what is the high priority? I2 should come. Whether I2 will come or not, let's check our design. I2 is 1, I1 is also 1. Assume I3 is not 1. I3 friend is 0. Only I2 friend and I1 friend came. Out of them, who will come in the output? Let us check it. 0 and 1. What is the answer? 1. Now this is 0. What is 1 bar? What is 1 bar? 0. 0 into 1, 0. 0 plus 0, 0. Oh, so who win the match? I2. When I2 and I1 are fighting, who win the match? I2 win the match. I2, I1, both of your friends came, then you gave priority to your friend 2 rather than friend 1. So it is working fine. You accepted or not? Now you can check I3, I2, I1, I0. Out of them, any one of them can be given as your inputs and check which one will give you the output. Definitely, this will give you highest priority in the output. Is it okay, everybody? Now you can take, if required, one enable in your output line, which will not make any much cost other than AND gate, or you may take one tri-state buffer. Now, I am giving you one small homework. Implement 4x2 priority encoder with following priorities. I2, I1, I3, I0. This is the least. This is the highest. Okay, first priority to least priority. What is the priorities I am assigning? I2 is the high priority, I0 is the least priority. I1, I3 are different. Like that, here this table should be changed. How to change? When I2 comes, remaining can be anything. Sorry. You should design like this. When I2 comes, remaining can be anything. 1, 2 should come. Like that, according to your requirement, if you change this table, you can design with any priority of your wish. You can give priority to any of your friends. Priority need not be same every time. Is it okay? Very good. Yes, the same process. Na? Only the table change accordingly. Your truth table came maps accordingly. Your design will. Okay. So shall we move further? Accordingly, you should make the designs. That's why for practice you can try this problem. So that is about your encoder. The next one we are going to discuss is ROM. What is this ROM? Read only memory. Still, you take any order, it doesn't matter. But in the design, this table should be modified. When 2 comes, remaining can be anything. 1, 0. Okay, similarly, when 2 is 0, 1 should be 1, 3 can be anything, and this I0 can be anything, 0, 1. Like that, accordingly, this table should be changed. Order can be, doesn't matter. Okay, read only memory. Then you may get the doubt. Sir, M for memory, you said combinational circuits are not having any memory. Then why you are saying this in the combinational circuits? Even it is a memory, it is for the namesake, if it is a memory, but still it is called as a combinational circuit only. That I will prove it and explain it. Just wait for some time. Okay. Still, ROM is considered as combinational circuit only because it will not be having any feedback path. Its output is not depending on the previous values. Okay, I will prove that. Don't worry. But it can store the data. For what? Akash? Cam scanner for what? Yeah, whether why he is asking for which purpose? PDFs? No, where is the PDF? These are not PDFs, man. These are just screenshots. I will do the work in easiest possible way. I just write it in the MS Word. I take the screenshot and I just crop it and give it. I don't make all those things. Make the things as easy as possible. Even in the class also, I took screenshots so many times. I hope you know it already. Okay, just 1 minute. Wrong. Wrong. Okay, ROM is a combinational circuit. I think some snipping tool is by default there in my OS. Just crop part only. Yes, so let's come here. ROM. ROM is a combinational circuit which contains a decoder at the input stage or gates at the output stage. Let's see the structure of the ROM. So see here. Actually, we can write everything in the class itself, but my intention is not to type. Originally, I am also more lazy than you. But if I make some slides prior to the class, I make little effort for this. I can save more time. I can deliver you more examples and more problems. That is the intention. So wherever it saves our time, I will make that slide where it is possible. So listen here. This is an example, classic example of your what we call ROM, ROM. So here you have n input and 2 power n outputs decoder. Okay. So this is 0, 1, 2, up to how much? 2 power n minus 1. You will be having one enable input. Now you see here, this is a having n inputs. Now technical name for this is n address lines. What is the name we use in the memory? N address lines, which will select 2 power n addresses. So you can see this is nothing but 2 power n addresses. Okay, I don't know the spelling much. Okay, or locations. Is it clear? It is n address lines will select 2 power n addresses. Okay, or locations, memory locations, you can say. So at each location, you will be having m OR gates. What are they? These are called OR gates. M OR gates. Don't consider it as a one input OR gate. I will explain. Just wait. This is having m OR gates, which will tell you m bits of data at each location. In every location, m bits of data. M can be 2, 3, 4, anything. Okay, now see here how you store the data, how it will work like a ROM. Why it is called ROM, sir? It is simple OR gate and this decoder only, na? So why it is called as OR? Now I will explain you. Don't worry, just listen here. Let's make some connections from this point. Randomly I am doing this. Okay, so these are the connections I made here like this. Now, what does it mean? What is the meaning of these connections? Let us see here. So from here, please understand, this is not a single input target. It is not single input target. What is the meaning of this cross is, from this cross, one input go to OR gate. From this cross, another input go to OR gate. So what does the original meaning is, two input target, one input from here, one input from here. But we show simply like this. Simply we make a cross to represent, from this one input go to OR gate, from this another input OR gate. So please understand, this line and these lines are not touched until I show the cross. From the cross, one input go to OR gate. Please understand that. They are like this. You understand? They are not touched. They are like this. Okay. So these are, from here one input goes. From here one input goes. From remaining parts, it is not connected. Yeah, here it is randomly. For example, only I made. There is no meaning for this cross. Sushil, yes, some people might have that doubt. These crosses are made just randomly for giving one example, one feel. Okay. Now, for example, see here. For example, I keep all zeros. I keep everything zero here. Then this fellow will become one. Remaining all fellows will become how much? Zeros. So whether you have connection or not, remaining all inputs of the OR gates are zeros only. Accepted or not? Yes or no? Please carefully understand. I keep 0, 0, 0. This line becomes 1. Remaining all lines becomes 0. So irrespective of the connection, all these lines are 0. So remaining all inputs of the OR gates are already 0. Now tell me, what is this line? Is it connected or not connected? Comment. Is it connected or not connected? Everybody comment. Yes. It is not connected means remaining already zeros. No other connection is there. What is the output of this OR gate, friends? Okay, yeah. Now this is connected or not connected? Connected. From here one fellow will come here, then output is will be 1. From here also 1 will come. Just stop commenting, just listen here. What does it mean? Whenever I keep this address, every time I keep the address, I made the connection fixed here. Okay, every time I give this input, I will get 0 and all. I mean, this one and this one, you will be getting it according to the connections. So indirectly, I stored this data here or not. I have not written anything. I just made some connections. But when I give this address, I am able to read this data. I have not written any 1 here, any 0 here. But just my connections made the magic to give me this output. Yes or no? Similarly, for example, listen. My input is 0, 1, okay, 0, 0, 1, 0. Data is not stored anywhere, just connections are made. When that one comes, that one will come in the output. No data is stored here. That is the magic. You can store means if these connections are in your hand, you can make it receive. This depends on whether these connections are in your hand or not. Will you be able to make these connections? Then you can write. Otherwise, you cannot write. You can read only. So it depends on the manufacturer. Okay, now please listen. Suppose my input is 0010. Hare Krishna Raj. So 0010. Uh, Small echo is coming. Fan. Whose fan? My fan or shall I decrease? So anyway, we are in the live. So yeah, maybe in my mobile it is there with it. Will it be a problem? Shall I log out in that? With it? Is it true? It's looking weird. So let me do a log out from there. If required, I will do that. It's an experiment. I don't believe, but let's try. I'm not playing it, so there is no chance of echo from there. Okay, leave it. So let's continue. Not much disturbance. Huh? So if required, I already made these headphones also ready. So tomorrow, if required, we'll use this. I kept everything ready. So we can test that tomorrow. Okay. So where we are, right. So suppose your input is 0010. Yes, those are noise cancelling one. 0010. So when it is 0010, then all are zeros except the second line. All are zeros except kya second line. Now what happens? Tell me here. Except second line one. Na? So here second line is activated. This fellow is activated. So when this fellow is activated, this will be 1. This will, because of the connection. Please understand, you have not written anything. When you give the input, this 1 is coming. Because of this connection, you are getting it in the output. Remaining fellows are zeros. You understand this pretty well, I hope now, how this is made. Okay, we have not written any single zero, single one here, but the connection is making the magic. Indirectly, when you make the connection, it is indirectly equal to 1. That is, when the connection is made, that fellow will give 1 in the output. When the connection is made, that fellow will give 1 in the output. Connection not made, that fellow will give 0 in the output when that line is activated. Yes, output is according to the connection. Yeah, it is. We cannot write. Ideally, it is a read only, but there can be variations like programmable read only, where you can program this part. Okay, those are possible. So please listen now. Yeah, that we discuss as if just next. Okay, these are nothing but yeah. If the manufacturer made it and give it to you, then it is predefined, which will do one particular operation. Say you purchase one binary multiplier, then he may implement it using ROM. Okay, just wait here. He may implement it in the ROM, some multiplier circuit, and give it. It will do the job happily, but you cannot do anything else. There it depends. Electrically erasable is there, UV erasable is there. Everything that part is different. RAM, SRAM, DRAM, everything we discuss in semiconductor memories topic. Now we need not worry about it. So in the combinational circuit only, this part we discuss. You understand, is it a combinational circuit or not? You have a decoder or gates. There is no feedback connection. That's why it is called as a combinational circuit. Actual sense, you are not storing any data here. Only connections are able to give you that particular required output. According to your requirement, you may make. So how you can use it, sir? Listen, let's just make one understanding here. What is the meaning of how to write ROM size? What is the ROM size here? What is the ROM size? Yes, 1 minute. ROM size is defined as 2 power n into m. What is that? 2 power n locations. It indicates m bits. I'll write it in the next line. Next slide. So ROM size is here 2 power n by m. What does it mean? 2 power n locations, and each location contains m bits of data. Each location contains m bits of data. That is the meaning of 2 power n by m. Now just come to the regularly used ROM size. Say if I say 1 KB, what is the meaning of 1 KB? 1 kilobyte, 2 power 10 into 8. That is 1024 locations and 8 bits per location. Okay, 1 KB. Okay, 2 power 10 is 1K in the digital terminology into byte. Byte means 8. It is B na, B for byte. Kilobyte. Okay. So that is the background of the ROM. Let's do one problem. Some interesting problems are coming. Total bits is 1024 into 8, right? Kilobyte. Okay. You purchase the memory now 1 gigabyte. Like that. So please listen here. Implement the following functions are using ROM of appropriate size. Now please listen. Let's see the implications or uses of the ROM. How we can use this ROM. Okay. To implement the logic functions, you can use it. How to implement, sir? So see here, how many variables? Number of variables. How many? 3. So you should use 3 to 8 decoder because you need 3 address lines. Okay. So take a 3 to 8 decoder. With 8 lines in the output. And how many functions are there? How many functions are there? 2 functions. So 2 OR gates are required. Two OR gates. We give you 2 functions F1, F2. So take 3 to 8 decoder. This is another way to show it. That's all. You have 3 inputs A, B, C, and the outputs are 0, 1, 2, 3, 4, 5, 6, 7. So very simple mode, just make the connections wherever you need the output. One should be 1 for 2, 3, 4, 6. What is the function 2? 1, 4, 5, 6. Indirectly, you have stored nothing here. You have stored 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, like that. When this line is selected, it will give 1, 1, which is true for the function 1 and function. This line will give you the answer of function 1. This one will give you the answer of function 2. What is the ROM size here? Yes. What is the ROM size here? 2 power 3 into 2. Very good. That's okay. That's all. That much. So that is the example. Okay. So let's do one more question. ROM size is 2 power n into m, where m is OR gates, n is this 2 power n addresses. 2 power n is here 8. How many OR gates are there? 2. That's all. Okay, Sushil. Okay, Aman. Is it clear? Yeah, people in the microprocessor will do 8 KB, 32 KB, 1 MB, whatever may be the problems of the memories, there will do it. memory interfacing topic is there when we discuss the microprocessor. Here, let me give you one good question. Get ready. Now trap. Okay. So I will set the trap and I don't say when it will come. Yes, right, Bhargavi. Yes, in the combinational circuit only. They are not nothing much to discuss in that. Okay, don't worry about it. Just a few minutes, it will complete. So listen here. Determine the wrong size required to implement the following function. What is the first one? To implement a binary multiplier which will multiply 3-bit number and two 3-bit numbers to find the square of a 4-bit numbers. Let's start. Okay, first case. Okay, listen please. First listen. How to make this binary multiplier circuit? Let me give you one concept here called as lookup table. What is lookup table, sir? Generally, if you want to make a multiplier, there are two ways. You make one arithmetic circuit, which will do the multiplication like we have done already in the earlier cases, binary multiplier implemented. Here, how we are going to implement is, we are not taking any arithmetic circuit. No adder is used here, no subtractor is used here. Here, how you are going to do it is, we simply do by storing all the results. How you are doing? By storing all the results priorly. This is what we call lookup table. Suppose you want to make a sinusoidal function. Instead of finding the calculation, one way is make one table. Whenever sine 30 comes, go to that particular row 30 and give the answer. This is what we call lookup table. In your computers, it will be used. Okay, like your log table. Okay, so lookup tables. These are called as lookup tables. So let me give you one example. Before that, if you multiply an m-bit number, some basics of multiplication I want to revise. Otherwise, you ask me other doubts. Okay, if you have a m-bit number multiplied with another n-bit number, what is the result, sir? Tell me. It will be m plus n-bit number. If you multiply a m-bit number with n-bit number, the result is maximum, not every time, it is maximum m plus n bits. For example, you have 11. It is a 2-bit number multiplied with 3 ones. It is a 3-bit number. So 3 sevens is 21, 16, 8, 4, 2, 1. Okay. So this is a 2-bit number multiplied with a 3-bit number. Result is how many bits? 5 bits. Any case, it will not be more than that. Is it clear, everybody? Don't ask me, sir, 11 into 1. Let me write. It is a binary. Okay. Sir, how you directly say? And I didn't say directly. Please, I note 21. So I directly write 21. 21 is 16, 4 and 1. In your mind, you can calculate 8421 that code. So let's come to the problem. So for example, m equal to 2 bit, n is equal to 2 bit. Okay. So let me take that example. A, which is equal to A1 into A1 A0, another number B, which is equal to B1 B0. I want to perform A multiplied with B. Is this okay? Yeah, just 1 minute. We have already one table made it earlier. When we did the comparators, let me use that. So just Let me give you one small understanding of this. This is my A1, A0, B1, B0. Okay, so this is your A and this is your B. And multiply A and B, whatever you get, that result is Y3, Y2, Y1. Let me take Y0 also, 4 bits. What is this? A into B. Will you accept this? Hmm. Okay, so now let's fill this table. I don't fill the total table, okay? No need also, because you know how to do the multiplication. So you should give these as inputs to your system. That is, these are nothing but given as ROM address. Okay, these are your address lines. And this is the data you will be storing in that address lines, which is nothing but multiplication of AB. Now you start telling me what is 0 into 0. Take these two numbers as one number, these two as another number. What is the multiplication of all zeros? Similarly, what is the multiplication up to this? It is all zeros only. I am not writing the whole table, which will waste our time. So what is here? This is 2. This is also 2. 1 0 is 2. 1 0 is 2. 2 into 2, what is the answer, man? 4. 4 means 0 1 0 0. Next, 1 0 1 1 6. Lastly, 1 1 into 1 1. Please understand, 1 1 means 3. 1 1 means 3. 3 3s 9, sir. How you got 12, man? Is it clear how to fill this table? Okay, so what you do is take a ROM. Take a ROM which is having the size of 2 power 4, which each location kitna bits chahiye humko, how many bits are required in each location? 4 bits. Store this data. Finish. When you give this input, you will get that required output. Simple job. Yes or no? So what is this example called as lookup table? So here, what is the ROM size required? You tell me this. What is the ROM size required? How many locations are there? 2 to the 4 zeros to 4 ones. Tell me, 2 to the power of 4 into each location. How many? Result contains how many bits? Each location, how many bits in the result, man? Tell me. 4. Okay, your job. Okay. So can I generalize? Can I generalize like this? This is called, what is that? Locations. This is data. 4 bits of data. Yeah, you want whatever the input you want to give, that those bits are given to address lines. Then result will be having already stored data for multiplication of those two numbers. I'm repeating, please understand. This you give it as input to the ROM, that is address lines. Then in that location already we store this data. Storing means connection. That's all. Okay. Everybody, is it clear? Now, can you generalize this answer like this? 2 power. Why it is 4? Because this is 2 bit, this is 2 bit, 2 plus 2, 4 bits, 4 combinations, 2 power 4. So can I say 2 power m plus n into m plus n? Is it okay? This is in general. So to implement Yeah, maximum only. No, worst case to be considered. This one, Sushil, 4 bits of data is to be stored in each location. Na? Each location means whenever the particular line is activated, it will give 4-bit data. To implement what binary multiplier, ROM size required is 2 power m plus n into m plus n. That's okay. Now, what is your first question? Find the binary multiplier which will multiply two 3-bit numbers. Let's start the answer. What is the answer? Your two 3-bit numbers here, m is equal to 3, n is equal to 3. What is the answer? 2 power 6 into 6 is the ROM size. Okay, next, listen here. Next, I don't give any hint. I will ask you to answer. Get ready. To find poll, I will conduct. Don't comment. Okay. Aditya, please don't comment. I will conduct the poll. Square of a 4-bit number. Are you ready? Just remember what square does. Square is also multiplication. Please keep that in your mind. You want to find square of a 4-bit number. What is square? What is square? It's a multiplication of the number with itself. So let me start the poll. Earlier you are multiplying two 3-bit numbers. Here you are multiplying a square of a 4-bit number. You are finding square of a 4-bit number. It's nothing but how to find the square of a 4-bit number. Multiply 4-bit number with 4-bit number will give you 8-bit number. I'm sorry. Aditya, please don't comment when the poll is going on. Deep, correct answer. Abhineet, Aditya, Mohan, Rushikesh, Harsh, Krishna, Sushil, Abhinay, and Ganesh. Right answers. Very good. So the answer is not 2 power 8 by 8. It is 2 power 4. When you find the square of a number, you don't take the two numbers and multiply. Yes or no? You want to multiply square of 3. Will you multiply 3? You know answer is 3. 3 is 6-bit only. But you don't take two inputs here. How many inputs are there here? How many inputs are there? Only one input is there. Let me write. For example, square of 2-bit number. Okay. So you have A1, A0. You don't have two inputs here, only one input here. This is where you need to apply your common sense. So this is your A and A square. That's all. What is A square? Is Y3, Y2, Y1, Y0. 0, 1, 1, 0, 1, 1. What is 0 square? What is 0 square is 0. What is 1 square? 1. What is 2 square? 4. What is 3 square? 9. What is the ROM size? Equal to Please see, what are they? Address. And what are they? Data. You don't give two inputs here. You want square of 3, you don't give 3 and 3, na? Yeah. Okay, what is the ROM size? 2 power 4 into 4. 2 power, sorry, not, sorry, here, tell me here answer only. Here it is, yes, 2 power 2 into, because 2 power 2, 4 locations, each location contains 4 bits. Yes, 2 power 2 into 4. So the general answer is 2 power n into n plus n. Okay. Next, that is for 4 bit, it is 2 power n is how much here? 4 into 8 is the ROM size. Okay. So let me give you one extra concept here, which is interesting. One minute. Just wait, Sushil. Just wait. Today also, I think you have some general doubt. I am not able to solve your doubt. Don't worry. Today, I will solve your general doubt, whatever you have. Ask Sushil. No problem. Hmm. EPA is 0 means, yeah, it is called as what? What do you mean by it? You will have mutually exclusive solutions in that case. There is nothing common, right? Bharti, very good. Yes, Sushi, don't worry, we can solve. I already, I can help you in the group also. So listen here. Here one interesting part. Here, one interesting part. Observe carefully. What is this? What is this? 0101. What about this one? Very good. So these two are same. Yes or no? Same. So you can also do like this. You give A1, A naught. I'm sorry, just wait. Let me write it properly. You take A1, A naught. You have 2 by 4, where you have 4. And don't take all the 4, you just take the 3 OR gates. What are they? Y3, Y2, Y1 only. And this Y naught is there now, you use it as it is. 1 minute. You are able to understand what I am saying, right? Y3, Y2, Y1. This you use it as Y1. So the minimum ROM size can be 2 power 4 into 3 also. It is true only for square, not every multiplication. Only for square. You check for what is that? Multiplication, it is not the same. This is different, this is different. Need not worry about it. Okay. It is true for which one? When you find the square of the number, this last bit and this bit will be same. Okay. Cube same size, input is same, output need not be same. Output is multiplication of 3 A's, na? You get 6 bit. In that case, you check whether you are getting the same in the output or not, right? Not the same, na? I'm saying how it is same. 2 cube require 1000. 2 square requires only 100. 4 bits are required. Input may be same. Input only same, not output. So if we use y1 as ground and again decrease the size. Yeah, y1 is yes. Who is that? Harsh. Okay, here y1 is 0. 1 minute. Very good. Who is that? Harsh. Yeah. So here what to do? Y3, y2, and your y1 is 0 means ground, and here this is your y0. So what is the minimum ROM size? 2 power 2 into 2. So here what will you get? For 4 bit ROM size in general, if you ask 2 power 4 by 8. What is the minimum ROM size? 2 power 4 into 6 also correct. Okay, done? Happy? Okay. Right. Yes. For cube, you can derive your own. Okay. But general answer is same. If you want a cube, it is m into m. That is a 3m will come. 2 power m into 3m. This is the general answer. Minimum you should check according to the question. Yes, people. Okay. If you want, you check 10 into 10. What is the answer? 100. 100 means 64 and 36. So 36 means 32 and 4. 16, 8, 4, 2, 1. Sorry. 1 minute, please. Yeah. So this 0 comes here and second bit is 0. You can check it. Always you check on your own. I mean, you can make your own observations. I'm also making like that only. I mean, I am also giving the observations only. You can derive nothing different. So that is about your ROM. So let me take little extra time. Yes. Just give me 1 minute. I'm searching for the question. Uh, Hmm. Okay, this I have already, I hope, given as a DPP or somewhere. So you have three functions. It is desirable to generate the three functions. Okay, with the functions P1, P2, P3, P4. I will explain. Determine P1, P2, and so on, P5. Is it okay? So let's do this question. So let's divide this phase into assuming three equal parts. Okay. So A, B, C. I will explain the concept behind that. Don't worry. Just concentrate for some time. F1 anyway. Yesterday you enjoyed. So F1. What is F1? A, B bar C. A bar B, C bar B, C. A, B bar C. A bar B, C bar B, C. What is F2? A, B bar C. A, B. A bar B, C bar. F3. A bar B bar C, B, C plus A, B, C bar. I already told you how to fill the K-map from the equation directly. So this is 1, 0, 1. This is 0, 1, 0. This is BC means B and C both should be 1. Next here 1, 0, 1. It is AB. A must be 1, B must be 1. A must be 1 here and B must be 1 means here. 0, 1, 0. Next 0, 0, 1 BC and ABC bar 1, 1, 0. 1. Right. So let's make the K-map. Pair. Don't, I am not taking this redundant. It's a conventional question given in one of the ES paper or gate only. So what is the function? Is a bar B plus a C. A bar into B plus AC. What is F2? It is AC plus BC bar. What is F3? It is A bar C plus B into what is that? Sorry, AB. So you can write this as any problem? Okay. You can write this as product term 1, product term 2, AC and AC na same product term P2, P3, P4 and P5. Now you will implement this in a different way. I will show you. Listen here. Oh yes, sure. What is ASU, man? You just give any B1, B2, B3, XYZ. Okay, your name, RUSH, anything. Nothing. It is just one product term, so the name is P1. Straight away you give the names, that's all. Okay, if it is same, give same name. It can be P2 or it can be P3, same name, doesn't matter. Because they are same na, AC and here also AC. That's why I gave same name. Now here you take 5 lines. 1, 2, 3, 4, and 5 lines. And here you should take AND gates. Okay. And now how many functions are there? 3 functions. So 3 OR gates. F1, F2, and F3. Very simple. Very simple. Here, very simple part. What is product term 1 is A bar B. Make connection at A bar and B. Second, AC. So make connection at A and C. Next, AC. Next, BC bar. That is B and C bar. What is the next one? A bar C. A bar and C. The next one, AB. That is A must be 1. B. Is it clear, everybody? So here you take this product term 1, 2, 3, 4, and 5. You take P1, P2, first function is done. P2, P3, second function is done. P4, P5, last function is done. This is a programmable OR, and this is a programmable AND. Total is called PLA, programmable logic array. Earlier, please wait. Earlier we implemented using ROM also. There, what is the difference? This AND gate is not in your hand. This internal AND gates are there, na? Internal AND gates. These are not in your hand. You are not doing this. So this part is fixed. This part is programmable in that case. But now, what is the difference? Everything is in your hand. You are making the connections. Okay, so some gates are common, you can save. So this may be coming with a fixed structure in the IC. You may be making the connection so to implement the functions. Some gates may be common. If they are common, you may be able to save some hardware. Okay, decoder is not needed. Okay, if you use here, let me give you the what I want to give you. Yeah. So this is what we call, these are what we call programmable logic devices. PLA means programmable logic array, PAL means programmable array logic. Okay, now see here. Please listen carefully. If this part ROM may, what is the condition is OR gate is fixed, AND gate also fixed. Will you accept it or not? For ROM, PROM, AND part is fixed, but OR part is programmable. This is what we discussed. Decoder is fixed, OR gate is programmable. There is another case called programmable array logic where OR part is fixed, AND part is programmable. Last case is what we discussed just now. This is both are programmable. This table is very important. So many times questions came from this table itself. Mainly in the IES objective 1 mark questions, it is important. Oh yeah, this question is gate previous question only, conventional question. I have included in DPP also one question that I will do it now. So please, how to remember this, sir? So to remember, I will give you small shortcut. Here OR is there, na? Remember, R is programmable. Here A is there, sir. Here also A there, sir. So what to do, sir? My mind will be disturbed. Remember as programmable and logic. You remember in your own way. Okay, because there will be confusion. PLA or PL, which one is fixed by, which one is programmable by. So no doubt, PL you always in mind, programmable and logic you remember like that. Programmable array logic you remember as programmable and logic. So end part is programmable in that. Here R part is programmable. In that whatever we discuss here is both are programmable. Programmable means you are able to mark the connections. What is ROM one? Okay, listen here. ROM means manufacturer will do both of them. Nothing is in your hand. He will make it and give it, ask you to use it. Why fixed means you are not able to implement the functions in that case. He has already implemented some multiplier and gave it to your hand. You will be using it. That's all. Both are not in your hands. Everything is fixed by manufacturer. If you're able to play with the OR gates, that is connections is in your hand, you are able to do it, then it is programmable OR. What is the original meaning of PROM? Programmable read-only memory, where OR gates are in your hands. If AND gates are in your hands, PAL, both are in your hands, PLA. You should remember like PAL, here OR is programmable, here AND is programmable. You should remember these things compulsory. So now, let me do one question from your DPP only. Got it. This is a his recent gate 2000. What happens, Aditya? What I need to say? Sir, decoder and R is what? What do you mean by what? Decoder and R are some gates. What is your question? I'm not able to understand. Decoder and OR gate together is called ROM. If your OR gates are in your hand to program it, it is PROM. If it is fixed, it is not PROM. That is whether manufacturer has done this or you are able to make the OR gate. You are able to play with OR gate or not able. That will tell you whether it is PROM or ROM. So this question now it is very easy for you. Let's see. You have made a programmable logic array shown in the figure. What is F? This much simple question appeared in your gate 2017, I think, 2 marks question. Tell me the answer quickly. This is P bar, Q bar, R. What is this one? P bar, Q R. P bar, Q bar, R plus P bar, Q R plus P, Q bar, R. If you don't know concept, this much simple question may be missing you 2 marks. 2 marks easily, freely. What happened? If it is not option here, some other option here. What is it? Change it according to our requirement. Who will stop us? Okay. We should write our own. Aditya, just take this table into your mind. Keep it. Already I have explained this table. Okay. Same thing. You should mug up this. I gave you the way to remember it. If you are not able to do that way, just mug up. You should make your own way. Okay. There is tri-state buffer here. It is not tri-state buffer. It is a P bar. It's a buffer and inverter. Thank you for asking. As long as Nishita, please listen. If you are doing this job, it is programmable. If manufacturer do this and give you, you are not able to change it again. It is fixed. Those ROMs we have implemented. Now, if you implement here, we are not whether we implement or not doesn't matter. Here only size calculated. So whether you may implement or he may give you. If he is give you, it is only ROM. If you are doing this, it may be PROM. It depends on what you are using. But memory size is same both the cases. Okay. So please, someone asked me very good. This is not buffer, tri-state buffer here. This is like inverter buffer. You give P here, na? It will give you P. It will give you P bar. Yes. So I think 10 more minutes I will take. So let me please listen. Upload few good questions for your homework. Otherwise, one thing I will do. Can I give you the key for the last DPP so that you can check it? 28 questions. Last DPP key at least so that you can try, you can check whether your answers are correct or not. I already made the key ready with me so that I thought of discussing it today in the class itself. So first one is B, third one is BCCBA. My pick is not good. That's why otherwise I also do that, you know. Na? In group anyway, I'll send the pick. Don't worry. I made it in a random order. That's why. Yeah, for that background work is going on Magna. Before the course ends, I will make that PDF. Don't worry. A handwritten is there. I am trying to make it typed. Get it typed. So these are the keys for you. You have any doubt, just message in the group. Don't worry. Any particular question. Combinational. So today, please message me in the group once. I remind me. I will provide you that combinational circuits notes. Okay. So please practice the DPPs. Don't leave it. Okay. It is for your practice only. Please practice. Check it. If you have any doubt, utilize your groups properly. Thank you. So shall we end the class, or any particular single doubts, individual doubts are there? You can ask me. Let me give you two more homework questions so that I will be more happy. Good night. Good night. I am uploading some questions. Meanwhile, you can leave if you want. I mean, nothing will be discussed. Just to practice, I am giving you some questions. Good night, all. Thank you. So tomorrow, freshly, we'll start the sequence. Okay. Anyone having individual doubts, just wait. Okay, that's all for your homework part. Anyone having some doubts? How NAND came, please once. 1 minute. People, please remember this table as it is. Okay. So if everything is fixed, it is read-only memory. If OR gate part is programmable, that is you have done a decoder and OR gates. If OR gate part is programmable, if it is in your hand, then it is programmable read-only memory. If AND gate is programmable, then it is called programmable array logic. Okay, good night, Deep. If both are programmable like this is in your hand, this is in your hand. If both are in your hand, then it is called PLA, programmable logic. To remember easily, you remember it as programmable AND logic, programmable OR logic, programmable read-only memory, or you remember. So who is other? Amitabh is there. My dear Amitabh, yeah, what is your doubt? Very good night. How NAND came? Why, Amitabh, what you did when I'm explaining that part, why you didn't ask me? You have that liberty with me. Listen here, this question I think you are asking, right? Is this? Yes, very simple. Here these are max terms. I want to convert into min terms because I want to implement as min terms. How to convert max terms into min terms? When any one of the input occurs, it becomes 0. But I want to convert them into 1. So to convert into 1, good night people, convert into 1, you should take one inverter here. Yes or no? Then bubble will cancel. Then you will get bubbled OR gate actually. Bubbled OR gate is nothing but NAND gate. Is it clear, Amitabh? Tell me. Yes. 1. What is your doubt, Sagar? Please copy paste once. I think it is went. Yes, max terms means when that particular thing occurs, your output should become 0. So what is your doubt, Preeti? Sir, we need to consider carry and when not. Which carry? This will not be considered. Okay. In the addition, we should take this part only. I told already na, in the class. Whenever you add 6, this carry sometimes may give right answer, sometimes will not give. So to avoid that problem, when you add the carry, just directly take C out as your carry. Preeti, please ask me if you are there. Sagar, copy paste, then I can help you. How to find maximum PI and EPA of n variable K map? It depends on the function. Okay. I already told you what is the rule. In any function, output terms, that is the prime implicants. In the output, it is 2 power n minus 1 originally. That is not true for normal, but in the output, your PI is 2 power n minus 1. So because EPI is a subset of PI only, EPI cannot be more than PI. There may be all EPI condition, that is XOR gate. All EPI. Okay. Sagar, let me explain. All EPI is a XOR gate condition. That is 2 power n minus 1. Priti, you are there? I think she is not there. So let's end the class. Thank you very much, guys. So tomorrow we'll start freshly. Good night. Good night all.